In this next part of the section, we're going to be talking about writing equations from solutions. So when we do this, we write a quadratic equation having the given numbers, we'll give you a set of numbers, as the solution. So basically, we're working backwards. Let's look at the first set of numbers. The first set of numbers is -7, 3. So -7 is one solution and 3 is the other solution. So I could rewrite these as x equals -7 and x equals 3. This is just better notation. And then from here we can set those two equations equal to 0 by adding 7 on the first equation to get x plus 7 equals 0, and on the second one subtracting 3. This gives me x minus 3 equals 0. Now that both my binomials are set equal to 0, I can multiply them to each other. Notice that we're just doing the opposite as what we were doing when we were factoring. Now we're going the other direction. So now I rewrite the two binomial equations. It sounds kind of weird to say that, but x plus 7 times x minus 3 as a product equal to 0. And from here, I FOIL. X squared minus 3x plus 7x minus 21 equals 0. So my quadratic is x squared plus 4x minus 21 equals 0. So to recap, this equation, quadratic equation, has solutions -7 and 3. It's opening upwards, and so the intersections with the x-axis are at -7 and 3 with as a parabola opening upwards. So this is basically what we're doing. If we wanted to graph the parabola, we would change this equation to a function, and this would be the function f of x is equal to x squared plus 4x minus 21. Let's look at the next set of solutions. We have 4 and 2/3. First, I set each of these solutions equal to x. So I have x equals 4 and x equals 2/3. Then I bring all my values to one side and set the equation equal to 0. Subtract 4 from both sides gives me x minus 4 equals 0. On this second one, notice I have a fraction, so I'm going to clear the fraction first. By multiplying by 3 on both sides, this gives me 3x equals 2, and then subtract 2 from both sides, giving 3x minus 2 equals 0. I now have two equations, both of which equal 0, and so I can now multiply those two binomials together, where the product will equal 0. So x minus 4 times 3x minus 2 equals 0. And now I'm going to FOIL. And when I do that, I get x squared minus 2x minus 12x plus 8 equals 0. And then I'm just going to rewrite this as a trinomial with the two terms in the middle combined. X squared minus 14x plus 8 equals 0. This is now a quadratic equation with solutions 4 and 2/3. Again, if you wanted a little more context, we could say that the solutions to this equation are 4 and 2/3, and it is a polynomial quadratic with y-intercept at 8. And it's opening upwards. And if we wanted to graph it as a function, this graph that I just sketched very quickly would be f of x is equal to x squared minus 14x plus 8. In part C, we have two radical or solutions with radicals in them. And so I'm going to just do the same thing. It might be a little more tricky, but we'll still be able to get a quadratic. X equals 2 root 5 and x equals negative 2 root 5. Bringing those radical terms over, we'll get x minus 2 root 5 equals 0 and x plus 2 root 5 equals 0. Now we can multiply those two solution sets together, they're binomials now, and find the product equal to 0. X minus 2 root 5 times x plus 2 root 5, and we'll have x squared minus 4, and then it'll be the square root of 5 squared, which just will be a 5. So we can say x squared minus 20 equals 0. To know what the two solutions are, well, they're at the point negative 2 root 5 and positive 2 root 5. The parabola opens upwards, and the y-intercept is at 0, negative 20. My function is opening upwards, and the form for the function that I just sketched would be f of x equals x squared minus 20. Now this last one, we can still write it as a quadratic equation. Again, we set each of my solutions equal to 0. I need to set them equal to 0. First, we'll set them equal to x. So I have x equals 3i and x equals negative 3i. Setting them equal to 0, I'll have x minus 3i equals 0 and x plus 3i equals 0. Now I'm going to multiply them together, and the product will equal 0. X minus 3i times x plus 3i equals 0. And then when I FOIL them, I'll get x squared plus 3ix minus 3ix adds to 0, and then minus 9i squared equals 0. This gives me x squared plus 9 equals 0, and I have my solution. There are no y-intercepts, but I guess I could actually sketch this. It's just a parabola shifted up 9 units, so the y-intercept is at 0, 9. So there are no obvious roots, real roots of this quadratic, but the function could still be sketched. F of x equals x squared plus 9 with no x-intercepts, which is why you get solutions with I in them.